Now we're going to apply induction in divisibility proofs. Take a look at the following. In this example, I ask you to prove that for all integers, like n larger than equal to 0, 2 to power 2n minus 1 is divisible by 3. Very good. So what do we have here? We're going to show that if n is larger than equal to 0, then 3 divides this number, whatever that number is. So 1, 2. Show that 3 divides 2 to 2n minus 1, or we're going to show that 2 to 2n minus 1 can be written as 3 times any other integer like L, T, anything that you feel comfortable working with. The letters are not important. Very good. So we're going to apply the induction method. Let's work with the very first step, basis step. Guys, in your exam, in your homework, you need to mention which step you're working with. The basis step, it means that we need to show that the statement is true for the smallest value in the domain. They show that the statement is true for n equal to 0. So what's the meaning of that? I try to show that 3 divides 2 to power 0 minus 1. I'm going to put a question mark in front of it because I haven't shown it yet. I tried to do it. So to show that 3 divides 2 to power 0 minus 1, 1 minus 1, or 3 divides 0, we use definition. By definition, 0 can be written as 3 times 0. We already know that. So 3 divides 0. We're good with the basis step. We just showed that 3 divides 2 to power 0 minus 1. Check. Let us move to inductive step. We're going to get a little bit creative. In the inductive step, we're going to show that if P of K is true, it means that if 3 divides 2 to power 2k minus 1, we show that pk plus 1 is also true. So we try to show that 3 divides 2 to power 2 k plus 1 minus 1. Put a question mark. This is what you try to prove. If this guy is true, you want to show this is true as well. Okay, very good. Somehow I have to use this, that 2 to power 2k minus 1 is divisible by 3. Okay, so first you have a statement here. You have this number here. Break this down. Break down 2 to power 2k plus 1 minus 1. This guy, 2 to power 2k plus 1 minus 1 is equal to. So just go back to algebra. Distribute 2 into parentheses. You get 2 to 2k plus 2 minus 1. But what is this number? This number is 2 to power 2k times 2 to power 2. 2 to 2k times 2 to 2, just the basic algebra. Recall that. 2 to power a plus b is 2 to a times 2 to b. It's pure algebra. And you have a subtraction here, minus 1. So this guy can be written as 2 to power 2k, but 2 to the second is 4 times 4 minus 1. Guys, remember, multiplication comes first. It's not 4 minus 1, 3. It's a common mistake. Now break down 4 into 3 plus 1. This is 2 to 2k, 3 plus 1, minus 1. Now distribute this guy into parentheses. What do we get? We get 2 to power 2k times 3 plus 2 to power 2k minus 1. Now stop. Try to analyze this. This addition, subtraction, what is this guy? First of all, the very first thing that I see here is that this very first term has 3 next to it. So 3 divides 2 to power 2k times 3. This is obvious. It already has the factor in its form. Now take a look at 2 to 2k minus 1. I already know from pk this is true. By inductive step, assumption, 3 divides this number. 3 divides 2 to power 2k minus 1. So, as you can see, 3 divides the first term. 3 divides this term. So, the conclusion is 3 divides their sum 2 to 2k times 3 plus 2 to 2k minus 1, which is the same as what we have started, 2 to power 2k plus 1 minus 1. 3 divides 2 to power 2k plus 1 minus 1. But this is what we tried to prove, pk plus 1. So by induction, we just prove that. This is your conclusion. Let's write down the conclusion here so we have enough space. This is pk plus 1, which is true by the method of induction. We prove that 3 divides 2 to power 2n minus 1 when n is larger than or equal to 0. So we have a nice formula. Whenever you want to use this formula, you can say that, hey, I proved this by the method of induction, and now I can apply this formula. Divisibility by 3.